So now I'm gonna tell you about operating system structure in Symbian Nokia. The structure of the Symbian OS can be divided into 4 main layers. So number 1 is kernel layer. At the lowest level, the kernel layer provided core system service and device driver. It handled low-level tasks such as memory management, process scheduling, and device control. The Symbian kernel was known for its efficiency and real-time capabilities. So number 2 is operating system service layer. This layer provided higher level service and libraries to the application running on the device. It includes components such as file system, networking protocol, multimedia framework, and telephony service. This service allowed developer to build application that could interact with the underlying hardware and utilize various system resources.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid Irfan bin Ahmad Bazli, and my number matric is 071028. Now, I will explain about the middleware layer and application layer. Middleware layer. The middleware layer acted as an interface between the operating system, service, and the application. It provided a set of APIs, application programming interface, that developer could use to access various system functionalities. The middleware layer included component for graphic rendering, messaging, data synchronization, and location-based service, among others. Next, application layer. This layer consisted of the user-facing application running on the Symbian device. It includes a wide range of built-in applications such as messaging client, web browser, media player, and productivity tool. Additionally, third-party developers could create their own application using the provide APIs and development tools.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hakim Rifki Menowazi. My matric number is 070796. Okay. Deadlock handling. In general, a deadlock is a situation that occurs when two or more processors in an operating system or subsystem in device like Nokia are waiting for each other to release resources or performance action, causing them to become stuck in a loop and unable to proceed. This can result in a system freeze and crash. If you are experiencing a deadlock issue with your Nokia device, you may want to try restarting it or contacting the Nokia customer support team to further assistance. This example for deadline handling. Transaction A might hold a lock on some role in the account table and need to update some role in the order table to finish. The sum of deadline handling. Configuring deadlock detection and lock wait timeout. You configure the amount of time a transaction waits before the B does any deadlock checking with the deadlock timeout property. Second, debugging deadlock. If deadlock occur frequently in your multi-user system with a particular application, you might need to be some debugging. Programming application to handle deadlock. When you configure your system for deadlock and log wait timeout and an application could be chosen as a victim when the transaction time out.
Assalamualaikum. I am Muhammad Anik Aizat Najmi bin Muhammad Qasim. So I want to share about methods of handling deadlocks in operating system. Okay, it has I want to share 3 steps of this method. Okay, the first one is deadlock avoidance. Okay, when a process requests a resource, the deadlock avoidance algorithm examines the resource allocation state. If allocating that resource sends the system into an unsafe state, the request is not granted. Therefore, it requires additional information such as how many resources of each type is required by a process. If the system enters into an unsafe state, it has to take a step back to avoid deadlock. Okay, for the second step is deadlock detection and recovery. We let the system fall into a deadlock, and if it happens, we detect it using a detection algorithm and try to recover it. Some ways of recovery as follows. Some ways of recovery are as follows. Number 1, averting all the deadlock process. Number 2, abort one process at a time until the system recovers from deadlock. Number 3, resource preemption. Resources are taken one by one from a process and assigned to higher priority processes until the deadlock is resolved. Okay, for the last step is deadlock ignorance. In the method, the system assumes that deadlock never occurs. Since the problem of deadlock situation is not frequent, some systems simply ignore it. Operating systems such as Unix and Windows follow this approach. However, if a deadlock occurs, we can reboot our system and the deadlock is resolved automatically. So that's all from me. Thank you.
Process scheduling in Symbian OS was handled by its kernel, known as the EKA2 Epoch Kernel Architecture 2. The EKA2 kernel provides preemptive multitasking and implemented its own process scheduling algorithm. Processes. In the Symbian OS, the basic unit of execution is a process. Each process has its own address page, which is isolated from another process. Second is threads. Process in Symbian OS can have multiple threads. Threads are lightweight units of execution that share the same address space within the process. Threads are the schedule for the execution, not process. Lastly is priorities. Each thread as Symbian OS is assigned its priority value that determines its importance relative to another threads. Higher priority threads get more CPU times than lower priority threads. Priority value range from 0 to 255, with 0 being the highest priority. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Shakil Adib and I will explain about file and directory in Symbian Nokia. In Symbian OS used by Nokia smartphones, the file system was organized into directories and files. Here's a basic overview of how files and directories were structured in Symbian Nokia. for Nokia devices. Number 1 is drives. Symbian devices typically had multiple drives, each representing a different storage location. Second is root directory. Each drive had a root directory that served as the top level directory for that specific drive. Number 3 is directories. Directories were used to organize files and other directories. They form a hierarchical structure allowing for easy organization and navigation. Directories were visually represented as folders. Number 4 is files. Files were individual units of data stored within directories. They could include various types of content such as document, images, videos, and application. Each file had a unique file name within its directories. Okay, number 5 is file path. File paths were used to specify the location of a file within the directory structure. A file path consists of the drive letter, directory's name, and the file name. And number 6, the last one, is file operations. User could perform different operations on files and directories, such as creating, deleting, copying, moving, and renaming. These operations were typically carried out through the phone's file manager.